Hello everyone and welcome to our channel, Mootechie. It's so wonderful to have you with us today as we dive into the fascinating world of chemistry. We're going to explore a fundamental topic that you'll encounter everywhere: acids, bases, and specifically salts. So get comfortable and let's begin our learning journey together. Now, let's explore what we'll be covering. We'll start with the definition and characteristics of salts. Then we'll move on to the preparation of salts and the different types of salts. Finally, we'll discuss the uses of salts and their hydrolysis in water. Coming up, we'll discuss the definition of salts. A salt is formed when all or part of the ionizable hydrogen of an acid is replaced by metallic or ammonium ions. It consists of all aggregation of positively charged metallic ion and negatively charged acid ions. Next, we explore the characteristics of salts. Our first characteristic is water of crystallization. This can be defined as the definite amount of water that some substances chemically combine with when they form salt, and such salts are referred to as hydrated salts. When heated, they give off their respective water of crystallization, and by so doing become anhydrous salt. Let us now look at another aspect of this characteristic: crystalline shape. Examples of salt with water of crystallization are: when hydrated, they are crystalline in shape, but when heated and the water of crystallization is released, there's a loss of crystalline shape. For instance, we have sodium trioxyl sulfate, 4-decahydrate, which is Na2SO3.10H2O. Another is iron 2-tetraoxyl sulfate, 6-heptohydrate, FeSO4.7H2O. And sodium trioxyl carbonate, 4-decahydrate, Na2CO3.10H2O, among others. Moving forward, we'll see the second characteristic: efflorescence. This is the loss of part or all of the water of crystallization from a crystalline salt when exposed to the atmosphere to form a lower dehydrate or the anhydrous salt. For example, substances like an Na2CO3.10H2O, which is washing soda. Now let's talk about the third characteristic: deliquescence. This is a phenomenon in which a substance absorbed moisture, that is, water, from the atmosphere when exposed and turns into a solution. Examples include CaCl2, FeCO3, CuCO2, and ZnCO2. As we continue, let's understand the fourth characteristic: hygroscopic. This is a phenomenon in which a substance absorbed moisture from the atmosphere when exposed and does not turn into solution, but merely becomes sticky or moist. For example, sodium trioxyl nitrate, 5-NaNO3, potassium trioxyl nitrate, 5-KNO3, and sulfuric acid, H2SO4. Hygroscopic substances are commonly employed as drying agents and desiccants. Now, let's move on to a closer look at drying agents or desiccants. These are substances that have a strong tendency to absorb moisture or water. They are used to dry gases in the laboratory. A drying agent cannot be used if it reacts with the substance to be dried. That is why H2SO4 cannot be used to dry ammonia gas, because they will react to form ammonium tetraoxyl sulfate, 6. The reaction is 2NH3 plus H2SO4 yields NH42SO4. Next, we explore the preparation of salts. The method chosen to prepare a salt depends largely on its solubility in water and its stability to heat. First, let's discuss the preparation of soluble salts. One method is the reaction of acid and metal. Here, the more reactive metal, like calcium, magnesium, zinc, or iron, directly displaces the hydrogen ion in the acid. For example, zinc plus 2HCl yields ZnCO2 plus H2. Another method is the reaction of alkaline and acid. Salts are formed when acid reacts with alkaline. For example, KOH plus HNO3 yields KNO3 plus H2O. Another method for preparing soluble salts is using a dilute acid and an insoluble base. A salt is formed when a dilute acid is heated and the insoluble base is added to the acid until no more bases can dissolve in the acid. For example, 2HCl plus CuO yields CuCl2 plus H2O. Now let's talk about the preparation of insoluble salts. One way is through double decomposition. This is done by mixing two compounds, one containing the metallic radical and the other the acidic radical of the required insoluble salt. For example, H2SO4 plus CuO yields CuSO4 plus H2O. Another method is the combination of constituent elements. This involves the combination of the elements that make up the insoluble salt. For example, Fe plus S yields FeS, and 2Fe plus 3Cl2 yields 2FeCl3. Moving on, let's discover the different types of salts. There are 5 main types of salts. They are normal salts, acid salts, basic salts, double salts, and complex salts. First, a normal salt is formed when all the replaceable hydrogen ions in the acid have been completely replaced by metallic ions. For example, H2SO4 plus ZNO yields H2O plus ZnSO4, and HCl plus NaOH yields NaCl plus H2O. Second, an acid salt is formed when the replaceable hydrogen ions in acids are only partially replaced by a metal and are acidic to litmus paper. For example, H2SO4 plus NaOH yields NaHSO4 plus H2O. Let us now look at the third type, basic salt. This is formed when there is insufficient acid to neutralize the base. For example, CaOH2 plus HCl yields CaOHCl plus H2O, and ZnOH2 plus HCl yields ZnOHCl plus H2O. The fourth type is a double salt. This ionizes to produce 3 different types of ions in solution. Usually 2 of these are positively charged while the other is negatively charged. For example, potash alum or aluminum potassium tetraoxosulfate 6-dodecahydrate, KAlSO42.12H2O. This compound ionizes as follows. KAlSO42.12H2O yields K plus Al3 plus 2SO42 minus plus 12H2O. And finally, the fifth type is complex salts. Complex salts ionize in water to form complex ions. For example, sodium tetrahydroxyl zinc 2, Na2ZnOH4, and potassium hexyenoferrate 2, K4FeCN6. For instance, K3FeCN6 ionizes to give 3K plus FeCN6 3 minus. Now let's discuss the uses of salt. Sodium chloride is used in preserving food. Salts are used as drying agents and antifreeze. Salt is used in soap-making process to separate soap from glycerin. It is used in softening of water, for example, Na2CO3.10H2O. They are used in stabilizing dirty roads, and they are used in the production of toothpaste. To wrap up our session, let's understand hydrolysis of salt. Hydrolysis is the reaction of a salt with water to form an acidic or basic solution. When salt is dissolved in water, a solution which is either acidic or basic is formed. However, when other salts are dissolved in water, solutions that are not neutral are formed. These solutions may either be acidic or alkaline. So, what does this mean in practice? The solution of a salt of a strong acid and a weak base will be acidic, while a salt of a weak acid and a strong base will be alkaline. Let's see some examples. NH4Cl plus H2O yields NH4OH plus HCl. CuSO4 plus 2H2O yields CuOH2 plus H2SO4. Na2CO3 plus 2H2O yields 2NaOH plus H2CO3. And K2CO3 plus 2H2O yields 2KOH plus H2CO3. And that brings us to the end of our lesson for today. Thank you. See you in the next class. Author